All right, guys, so we're going to talk about 7.4 real quick. So I'll try to make this relatively quickly. We'll do a few of your homework problems, and then hopefully you can get the idea how to do this. So again, this is lesson 7-4, unit 7, lesson 4. So now you have a few properties that are going to seem pretty confusing, especially the first time you ever look at them. So you have one product property for the logarithm that says that if you have two things in the middle here multiplied, you can also rewrite them as log base b of m plus log base b of the letter n. Okay, so sometimes that can be used for expanding, sometimes that can be used for condensing. So for example, what do I mean by condensing? If I want to write this as a single logarithm, I can write this as log base 2 of 7 times 4 again. So when you add two logarithms with the same base, but the same base, I mean that little 2 that you see on the bottom, I can actually just multiply the inside. So this would be log base 2 of 28. Now this right here and that, if you were to put both of them in the calculator, you would have the same numeric answer. All right, next up. Same thing on number 2. If I am adding, remember this is log base 10. So this would be 25 times 4, which will give me log of 100. All right, and then finally, if you have something like this would give you log base 4 of 2x times 4x squared, which is going to give you 8x cubed. Okay? Now, if we're talking about expanding, some of this in the expanding part can be a little weird because log base 10 of 6 could be rewritten as log of 2 times 3. And if I want to expand this, I would write it as log base 10 of 2 plus log base 10 of 3. Okay? Now the 45, and you might be thinking like, well, how do I know in the 45 particularly how I'm going to split it up? I mean, you can split it up several different ways, like 9 and 5 or 3 and 3 and 5. The answer is it doesn't matter, right? So at least split it up into 2. If I divide this 45 is the same thing as 9 times 5, which means I can split this up into log base 7 of 9 plus log base 7 of 5. Okay? And then finally, the ones that I think are easier are the ones that have like a 5x, because I can split this up into log base 2 of 5 plus log base 2 of x. All right. Now, you have another property called the quotient property that says that if you have a log and you divide inside that log, this is the same thing as log base b of m minus log base b of n. All right, so for example, this one right here, you could write this as log base 3 of 24 over 8, which is 24 divided by 8 is 3, okay? Well, for example, in this one, you can write this as log base 2 of 15 over 15. Again, I'm only going to do that when I subtract. Okay, and if that happens, you can simplify that. And then finally, you would have this one, log base 4 of x to the 9th over x squared, which is going to give you log base 4 of x to the 7th. Now, of course, we can write this as fractions. Now, this one's a little bit, I'm not even going to do number 10 because I think that's just strange. But on number 11, for example, what I can do is actually, I can rewrite this as log, remember now I'm expanding, okay? So I want to take one logarithm and make it into at least two logarithms. 1 minus log base 5 of 3. And that's it for that, okay? On this one right here, number 12, this is log base 10 of m minus log base 10 of 7. All right, now we have the power property, which in my opinion is probably one of the most used one if you go into higher level math. So this n right here, this power can come to the front when you're expanding. So what does that mean? Well, when I have this 5, if I want to condense, I can bring this 5 up as a power. So this would be log base 4 of 2 to the 5th. Now 2 to the 5th is 32, but if you didn't know that, you could just leave it as 2 to the 5th. All right, so for example, this right here would be log base 2 of x to the 7th. Again, I bring that number, then I multiply and bring it up as power. And then finally, log of 8 to the 1/3. Okay. Now, when I'm expanding, it's backwards. If the power's up here, I'm going to put it to the front. So I have 7 log of 2 like that, okay? or this one right here in particular, I'm going to bring that entire power to the front. So I have x minus 1 times 3 log of 4. And you can distribute that log right there, but we're not going to, but it's the same idea. Okay, last but not least. Oh, you got to be careful when you have a square root like that. You could rewrite this as w to the 1/2 power, which would mean that you can bring that 1/2 to the front and write this as log base 7 of w. All right, now we're going to put it all together. Now, the weird thing about expanding, for example, so they want us to write this as a single logarithm. All right, so for example, when you do this, you got to do the power rule first, meaning if you have a number in front, you got to bring it up to the top. So before you do anything else, I need to do this part first. All right, so bring the powers up or bring the numbers up. And then after that, because I'm subtracting, remember 6 squared is 36. All right, so this kind of combined the power rule and the subtraction rule. Again, bring the power up first. Oh, that one is particularly strange. I did it too much, sorry, I mislooked at it. This 4 right here would go up here. So this would be log base 4 of 8 to the 4th. Let me make this a little bit thinner. And this 2 right here, I can put it up here. So this would be plus log base 4 of b to the 2nd. Now because I'm adding, I'm going to multiply those two. So this would be the answer for that, okay? Let's go to something perhaps more difficult. So sometimes you're condensing, sometimes you're expanding, but remember the rule is you got to bring this power up first. So if you see a number in front of the logarithm, bring them up. This is log base 6 squared minus log of 16 to the 1/4 plus log of 3. Now, when you have several of these in a row, you're going to do one at a time. I wish I had more space on here, but I don't. So what we can do from there is we can write this as log base 6 squared. Now, 6 squared is 36 over 16 to the 1/4. Now, you may not know this, but 16 to the 1/4 is the same thing as the 4th root of 16. And the 4th root of 16 is 2. Okay, so I'm going to replace this with a 2. So far, all I've done are those two, okay? Now, finally, what I'm going to do now is that plus log of 3 is going to multiply this by 3, okay? Now, if I multiply that by 3, many different ways to do that. And at that point, you can put the 36 times 3 over 2. Let's see, 36 divided by 2 is 18. I guess I should have done that. Times 3, so this would be log of 54. All right, so as you can see, it gets complicated. Now, if we're talking about expanding, you actually want to do that backwards. Instead of perhaps doing the power rule first, you're actually going to split this up. So for example, this one right here would be log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. And then you do the power rule, meaning you bring this power down now. Excuse me. So again, the goal here when you're expanding is to start with one logarithm and to end up with at least one more. Okay. Let's do one more here. There's lots of stuff here that you can do. Now, there's several ways of doing 29 particularly. I can... Probably distributing would be the best thing you can do. As you can tell, I just power to a power rule from the exponent lesson. You got that? Remember, this is a Q, not a 9. I know it looks like it. And then before I do not bring this power down until you write this as 2. This is a Q to the 8th plus log base 7 of r to the fourth. Then you can bring those powers down. So that power goes down. And then this. Okay. So it works like that. Now, let's do a few of the homework here. I know you're probably tired of hearing me talk, but let's just look quickly at the homework. Let's do all odds. Write your properties rules here. Those are the ones that I wrote in the notes, so make sure you write those. And then, for example, let's do perhaps one that's challenging. If you see something like number 7, right? Remember, the rule here is I want to condense. I want to make this logarithm, this 3 logarithms, into a single logarithm. Now, right here, I'm already halfway there. The powers are already up there. Okay. This is x squared. Now, this 4, I'm going to bring it up as a power. Now, if I have x cubed to the power of 4, that's going to give me x to the 12th. Right, so I'm going to multiply this now, or let me write it like that. Let me write it in step. This would be log base 4 of x to the 12th. So this would be log base 4. X to the 7th divided by x squared is x to the 5th times x to the 12th. So this would be log base 4 of x to the 17th. Okay. There's one now. On the other direction, it says to use the change of base formula, but let's not do that. Okay, let's just give me the answer. For example, on this one right here, you're going to bring the 1/3 up. So this is log base 4 of 8 to the 1/3 times 15. Now, why did I say times? Because I have a plus here. Okay. Now, 8 to the 1/3 is the same thing as the cube root of 8. So the cube root of 8 would be 2. I'm going to multiply it times 15. So again, 8 to the 1/3 power is the same thing as the cube root of 8. So this right here would be log base 4 of 30. Last but not least, when you get to this expansion ones, for example, I'll do 17 for, I'll do 15. Yeah, I'll do 15. Distribute that 3. So this would be log base 2 of a to the 6. Excuse me. A to the 15th, b to the 6th. And then if I do this, I would have to start with this step because I'm multiplying. And then I would bring those powers down. All right, so I hope that helped, guys. Sorry I couldn't be here. All right, and we'll see you next time.